Hello, this is Captain Chaudhari. Once again, I am with you for drydocking. In my last video, I talked about drydocking on a horizontal drydock, that is, declivity was 0. So, whatever was the initial trim, free floating trim, that was also the trim change that was required for the ship to sit all over. Now, we are going to do a different calculation. Many of the figures taken here are the same from the last question. Except for that the initial draft of the ship is 3.60 and 5.98 meters. Other particulars like displacement 6,000 tons, kg 7.6 meters, length 154 meters, LCF 75 meters, TPC 24, MCTC 218. Now km at the time of critical moment is 8.9. FSM is 400 tons meter, and as I told you, in every drydocking question, virtually the first formula should be trim change into 100 MCTC is equal to P into LCF. This P is P critical, the P that will be generated at critical moment. I told you at the start of critical period, the upthrust is 0, and gradually as the water level lowers, the P grows, and the maximum upthrust that is going to affect the ship or the initial block is this P, the P given by this formula, and this is called P critical. Thereafter, of course, we need not worry because this P gets distributed in different blocks. Now, here additionally in this question, what is stated is the declivity of the blocks. Declivity is required, for shedding out the water out of drydock. Declivity is 40 centimeter per 100 meters. So I want to know if the declivity is 40 centimeter for 100 meters, then for 154 meters it will be how much? So it will be the slope, if we want to say slope in meters, will be 154 into 0.4 divided by 100. 0.616 meters is the declivity of the blocks for the ship. So the trim change, of course this declivity is seaward and trim is also seaward because the ship is going to enter the drydock head first. So when the declivity as well as the slope, the declivity as well as the trim are of the same name, to find out the trim change, we subtract one from the other. So TRC is going to be whatever is the trim. Trim is how much? 2.38 minus 0.616. So it is going to be 2.38 minus 0.616. This is going to be 1.764. 1.764. We apply it in this formula. So we get P is equal to 1.764, that is a trim change, into 100 MCTC divided by LCF, that is 75 meters, right? So 1.764 into 21800 equals divided by 75 gives me 512.7 meters. So this is the 512.7 tons. So this is the upthrust at critical moment. This is called P critical, 512.7. Now we'll just note down this data and then do the question like trim changes 1.764 and P critical is 512.7 tons. Let's do the standard trim format. Start with the initial draft, that is 3.600 and 5.980. Bodily rise is 512.7, that is the P critical, divided by 100 TPC, that is 2400, gives me 0.214. 5.766, 3.386 meters and 5.766. Okay, now trim change is 1.764, right? So TRA, the change of aft draft because of trim change is going to be 1.764. Okay, into LCF, that is 75 divided by 154, that is LBP. So 1.764 into 75 equal to divide by 154 gives me 0.859, 0.859 minus, because the ship is touching aft, so it's like discharging the weight from aft, and this if I subtract from 1.764 would give me 0.905, 0.905. This will be plus. .291 and 4.907. Let us see what is the trim. When the ship sits all over, 4.907 minus 4.291. This gives me 0.616. 0.616. Is it the slope of drydock for the ship? This is the declivity of drydock for the ship. Let's see, let's confirm once again. It is 40 centimeter for 100 meters, so for 154 meters it would be 1.54 into 0.4 gives me 0.616. So after the ship sits all over, the ship attains the same trim as the declivity of the blocks for the ship, that is 0.616 meters. Now, as the ship sits on the blocks, now additionally, the ship may be supported now by the keel blocks. Let us find out what is the critical moment upthrust. Km at the time of critical moment is 8.9 meters. Kg of the ship is 7.600. So GM solid is 1.300 meters. Now free surface correction is going to be 400 divided by delta minus P. So 6000 minus 512.7. 6000 minus 512.7 is 5487.3. 5487.3. So free surface correction is going to be 400 divided by 5487.3 gives me 0.079, 0.073. So always negative free surface correction. So 1.227 is GM solid minus P kg upon delta minus P. So P is 512.7 multiplied by kg, that is 7.6 equals divided by 5487.3 gives me 0.710. 0.710. So this is the GM virtual, that is 0.517 meters. So practically, more or less, to find out the critical moment, the chief officer out at sea or the master out at sea would follow these calculations. These calculations are, in a way, the calculations for ship-shaped vessel. And one of the most important things to remember is when you are applying free surface correction or when you are using the KM, KM should be for the reduced draft. the draft that is acquired at the critical moment, not the initial free floating draft, because that will make a lot of difference in your answer. So I hope these two classes, this one and the previous one, is helpful to understand like how to do the initial basic calculations for the ship. Here I would like to say one more thing. You see, sometimes this GM at critical moment is not good enough. It's not up to the requirement of the company. So the various things which are suggested, to improve the GM is like reduce the free surface correction, of course, shift the liquids into one tank instead of having it in different tanks. Yes, of course. Sometimes a DB may be filled up, but there is complication with filling up of DB because you'll have to remove the DB and then refill the DB in the dry dock, because it is generally followed that the condition with which you enter the dry dock, in the same condition preferably you should come out of the dry dock. Then there is a problem of oil pollution, gas freeing of the tank, etc. And it takes a lot of money because the tank has to be filled up with a hose. There is no pump, and money is time is money in the dry dock. You don't want to spend that kind of shifting of the weight down is also a usual procedure that is followed. But one thing which a candidate must remember, right, a chief officer must remember, is you have seen in this formula the virtual loss of GM due to dry docking is P kg upon delta minus P. Now P kg upon delta minus P means that virtual loss of GM is directly proportional to P. And look at this formula. Trim change. Now if you look at this formula, P is directly proportional to the trim change. So eventually we can say that virtual loss of GM is directly proportional to trim change. If virtual loss of GM is directly proportional to the trim change, why not reduce the trim change? So this is a trick you must know. So maintain a trim at least what is told to you by the dockmaster, right? So minimum trim is decided by dockmaster and maximum trim is decided by your stability.